Today we're going to be practicing simplifying rational expressions. So first we're going to have to know the laws of exponents. So the first law says that a to the power of m times a to the power of n equals a to the power of m plus n. So we're going to add the two exponents when we multiply a number with the same base. So in this case it's a. A would be the same base, and then you're going to add the two exponents. So the second rule says that if you divide two numbers like that, then you're going to subtract the exponents instead. So just remember, when you divide, you're going to subtract, and when you multiply, you're going to add. And the third rule states that if you have a number that's already to the power of something, and then you're going to put that to another power, then you're going to multiply the two numbers. So in this case, it's a to the power of m times n. The fourth rule states that whatever's in the parenthesis, and if they're all in the parenthesis and the whole parenthesis raised to a power, you're going to write the exponent on top of both, or on top of all the variables in the parentheses. So in this case, it's going to be a to the power of m times b to the power of m. And then the fifth rule states that if there's a fraction in the parenthesis, then both the numerator and denominator gets the exponent. And other rules that you should know are a to the power of 0 equals 1, or any number to the power of 0 equals 1, and also any number to the power of a negative number equals 1 over that number. So for example, I'll just write an example right here. Let's say we have x to the power of negative 3. Then this is going to equal 1 over x cubed. Okay, and another thing to note, this second rule right here, some textbooks talk about things like if m is greater than n, or if n is greater than m, there's like different rules for it, but I don't really think you have to know that. You just have to know this rule right here, because, okay, I'm going to show you an example. So let's say you have x to the power of 5 divided by x to the power of 3. Then what you're going to do is you're going to subtract the two numbers. X to the power of 5 minus 3 equals x to the power of 2. And that works, but what if we have x to the power of 3 divided by x to the power of 5? And then the textbook, or a lot of textbooks, or a lot of other, I don't know, math sources have a different rule for this, but basically you just have to follow this rule and then another rule. So hold on, let me just show you. So then you just follow this a to the power of m minus n rule, and then you have x to the power of 3 minus 5. Then you just subtract those two numbers and you get negative 2. And then you just have to remember this rule right here, a to the power of negative n, and then you're just going to make this 1 over x squared. So this, you just have to follow these rules, and also just remember this bottom rule right here. Okay, so now we're going to do some practice problems, and I have the laws right here just in case you need to refer to them, but you have to keep practicing so that you don't need to keep looking at those laws. Okay, so it says simplify, and so first what I would do, so we can either simplify the things inside the parentheses first, or we can just start multiplying, or start looking at the squared up here. So I'm just going to start with the squared. So we're going to first look at this rule right here. And so everything inside the parentheses is going to be raised to the power of 2. So we have 3 to the power of 2 times x to the power of 2 times y to the power of 2. And then we're going to look at this rule, and we're going to say that the numerator and the denominator is raised to that power of 2. So we're going to have 6 to the power of 2 times x squared, and then that in parentheses to the power of 2 times y cubed to the power of 2. Okay. Then we're just going to multiply the numerator out. So we have 9x squared y squared over, so that's a 2. So it's 36. And now we're going to look at this third rule right here. And then we're going to look at this x squared, and we're going to square that again. So that means we're going to multiply the two numbers. So we get x to the power of 4. And same here, we're going to multiply 3 and 2, so we get y to the power of 6. And from here, we can just cross the numerator and denominator. And so, for example, we can go 9. You can divide 9 on the numerator and the denominator, and you can cross these out, and you get 4. You can cross the x's out, and you can get x squared, and you can cross the y's out, and you get y4. And so we have 1 over 4x squared y to the power of 4. And if you don't understand this crossing out thing, basically what we're doing here, so let me rewrite this part. Or actually, I'm not going to rewrite it. I think you can see it. So here we have or I'll write the x squared over x to the power 4, this middle section right here. And then what I did was I crossed it out and got x squared on the bottom. So what I was basically doing was I was following this rule right here, where I could subtract m and n. So you go x and 2 minus 4, and then we get x to the power of negative 2. And then following this last rule right here, we get 1 over x squared. And so that's basically the x squared that comes right there. So I guess it's the same method, but if you want to be really precise with it, then you can write this whole process out. Okay, I'm going to move on to the next question. So this question's a bit harder because it has 2 parts to it, but we're just going to approach this part first and this part. So looking at this part, we have to multiply the 2 and the 3, so we get x to the power of 6. And on the bottom, we have to make sure that everything in the parentheses gets raised to the 4th power. So you get x to the power of 4 times y to the power of 4 times z to the power of 4. And that whole fraction times, and we're going to look at this fraction next. And since we have a whole fraction in the parentheses, we're going to make sure the numerator and the denominator are both raised to the 2nd power. So we have z squared, and I'm going to write parentheses around that, to the power of 2 because of this part. Sorry, that made it look like an equal sign. Okay, over, then I'm going to make sure that the x and the y both get raised to the 2nd power. X squared, y squared. Okay, then I'm going to multiply this 2 times 2 because of the rule right here, 3rd rule. So I'm just going to rewrite this part, x4, y to the power of 4, z to the power of 4 times, and we have z to the power of 4 over x squared, y squared, okay? And then we can start crossing out and simplifying, or we can just multiply the numerator and the denominator. So I'll just go the long way, and I'm just going to multiply the numerator and the denominator. So we have x to the power of 6 times z to the power of 4 over x to the power of 4, y to the power of 4, z to the power of 4 times x squared, y squared. And then I'm going to start simplifying. So we have z to the power of 4 in the numerator and the denominator, so I can cross that out. And then we have x to the power of 4 and x to the power of 6, so I can subtract 6 and 4 and get x to the power of 2 on top. But then we have x to the power of 2 and x to the power of 2 in the bottom, so there's a lot of crossing out going on. But in the end, we're just left with this y to the power of 4 and y to the power of 2. So it's y and 1 over y to the power of, and we're going to add these two numbers. Remember, we're going to add when we multiply with the same base number. So we get 6. Okay. Moving on to the next question. So this question doesn't have any x, y, or variables. So we're going to focus on the 3 over 2. So we're going to raise both to the power of negative 2. So 3 to the power of negative 2 over 2 to the power of negative 2 times 4 to the power of negative 1 over 3. And in this case, we have negative 1 times negative 1. So we just get positive 1. Then remember that when we have a number to the power of a negative number, we're just going to switch and and move it to the opposite side. So for example, if it's on the numerator, we're going to move it to the denominator. So in this case, we have 3 to the power of negative 2, and it's in the numerator, so we're going to move that to the denominator. So we have 3 to the power of 2 on the denominator. In this case, we're going to move the 2 back up, so we have 2 to the power of 2 here, times 3 stays on the bottom because it's not to a negative power, but 4, sorry, I'm going to write a 1 there, because after we move the 4, there's going to be nothing on top. So we have 4 to the power of 1 on the bottom. Then we're just going to multiply these numbers out. So we have 4 over 9 times 1 over 12. Then we can divide by 4, so we get 3. So 1 over 27. So that would be our answer, 1 over 27. Okay, moving on to the next question. So this question, what I would first do is probably move everything out so that we don't have any negative exponents. So it's okay. Here I'm going to write the fraction. So 2 stays on the bottom. We have 2. F stays on the bottom. Now, or this f I'm talking about. Now we're going to think about this f to the negative 1. Since it's the negative power, we're going to move it down. So we have f to the power of 1, which is basically f on the bottom. Then we're going to look at this z to the power of negative 2, and since it's the negative, we're going to move it to the numerator, so we have z to the power of 2 on top. But we have z to the power of negative 3 on the numerator, so we're going to move that to the denominator. Okay. And now we can see we have z squared and z to the power of 3 on the bottom, so we can cross out. And if we divide that, we get z on the bottom. We're left with z. So we have 1 over 2, and then if we multiply 2f's, remember, I didn't write it, but this is actually f to the power of 1 times f to the power of 1. So we're going to add the two exponents. So we have 2. So we have 2 times f to the power of 2 times z. So that would be our answer. Okay. This is the last problem. Okay. Start writing here. So the first thing I would do is move everything in the parentheses so that we have no negative exponents, because negative exponents makes it confusing. So we have 4 to the power of negative 1. We're going to move that to the denominator. So we have 4 to the power of 1 on the denominator. But I'm not going to write the 1. I'm just going to write 4 because it's the same thing. And then we have m to the power of negative 2 on the numerator, so we're going to move that to the denominator. Then we have u. And I'm just going to write 1 on the top because we don't have anything. Oh, no, just kidding. I'm sorry. Take that back. U stays on the top because u has no negative exponent. Okay, but this is all to the power of negative 2 times, and then we have this part. So u stays on the bottom again. But the m to the power of negative 2 moves up, and we have m to the power of positive 2 and that whole fraction to the power of negative 2. Okay. So then I'm going to start using this rule number 5 right here, and then doing the numerator and the denominator to the power of negative 2. So we have u to the power of negative 2 over 4 to the power of negative 2 times m to the power of negative 4, because remember we're going to multiply 2 and negative 2, so we have negative 4, times m to the power of negative 4 over u to the power of negative 2. Okay, and then I'm going to start switching everything out again so that we can get rid of the negatives. So u is going to move to the bottom, so we have u to the power of 2, and then 4 is going to move to the numerator, so we have 4 to the power of positive 2 times m is going to do the same, so 4 to the m to the power of 4 times, and then u is going to move to the top, so u squared, and m is going to move to the bottom, so we have m to the power of 4. So now all we have to do is cross u squared out because it's both in the numerator and denominator, and m to the power of 4. So we're left with 4 squared, which is 16. Okay, that's the last problem. Thank you for watching.